Now students, in the last video we have discussed about the dimensional analysis, and in that section so far we have derived the dimensional formula around 30 physical quantities. This section, in this video, we will do the same dimensional formula and we will find some extra physical quantities and its dimensional formula. So next is the, so far in the last, if you recall, in the last section we got the dimensional formula of surface tension and the rate of flow of a liquid, rate of flow. From that fluid motion, another physical quantity that comes here is surface energy. Surface energy. So what is this surface energy? Remember one thing, consider a liquid in a container. The surface of the liquid, on the surface of the liquid there is surface tension, that is the property of a liquid, already I have told that. And surface energy is what? What is the potential energy? The potential energy is stored on the surface of the liquid per unit area. Means the formula is, for this physical quantity, let me write the formula. The working formula is the potential energy by the area per unit area. So this gives us the dimension of surface energy. So this is the physical quantity and this is the formula on what factors the surface energy decrease. So already you know the dimension of potential energy. Clear? So if you see the last video, already you know the dimension formula of potential energy. So to calculate the dimensional formula of surface energy, what I will do here now, to get the dimensional formula, next we will go for the potential energy. Potential energy is m1 L2 T minus 2. I am not going for detail. If you want to find, then the potential energy is equal to mass into acceleration due to gravity into height, and again the acceleration due to gravity is not a fundamental physical quantity. Then you go for the acceleration due to gravity, that is the velocity by the velocity, change in velocity by time. Then the velocity is again not a fundamental, the velocity is the displacement by time. Accordingly you will calculate the dimensional formula. Already you have derived that dimension formula. So this is the potential energy. Then the area is L2. This is the dimension of area. So if you put that, if you find the dimension formula, m1, this L2 get cancelled. So L2 to the power 0 and I will put T minus 2. Okay. Or I can write this as m1 T minus 2. So already you have got the dimension formula of surface tension and the surface energy and surface tension. If you see, the surface tension and surface energy both have the same dimension. Both have the same dimension. Now if you go for the SI unit, if you find the SI unit, I am not writing in column form, I will go for one by one. So in the last video we have gone for in a column form. So I am not doing that column, I am writing in the side by the SI unit. If you find the SI unit, from here also you can say that is kg and second minus 2. Or from this here, from this formula you can also know the SI unit, the joule is the unit of potential energy, joule per area means that is meter square. So joule per meter square. If you write the CGS unit, joule is or per cm square, that is or per cm square. So in that way you can calculate the surface energy. Okay. Then we will go for a most important that comes here in fluid mechanics, another physical quantity that is called as the coefficient of viscosity. Coefficient of viscosity. Okay. Now I will go for the coefficient of viscosity. So what is this coefficient of viscosity? The coefficient of viscosity, coefficient of viscosity. So what is this coefficient of viscosity? Remember, this coefficient of viscosity is S. So the coefficient of viscosity is the physical quantity which comes in your fluid mechanics. So what is this coefficient of viscosity? This coefficient of viscosity, when you calculate the coefficient of viscosity, if a liquid flows in a tube or in any basin, then the liquid flows in layers. In layer by layer, the liquid is flowing. Means, if the liquid is flowing, I will consider the flow of the liquid in layers like this. These are the layers, and this combined is the liquid. Suppose water flows, and we will say this is one layer of water, this is another layer of water, this is another layer of water. If two surfaces are moving, or there is a relative motion between the two surfaces, then there comes your friction. And what the friction in our solid case, in fluid or in liquid, that force is called as the viscosity. In liquid or fluid, the force of friction is called as the viscosity. Okay? So this coefficient of friction, coefficient of viscosity depends on the parameters like, it depends on the parameters like the force between the two layers, force between the two layers, and the distance between the two layers divided by force into distance between the two layers divided by area of the liquid layer, and that is another one is the velocity. What is velocity? Or the change in velocity of the liquid, you can say that is a velocity. So for the time being, to understand that, for the time being, to calculate the coefficient of viscosity, you remember this formula. When you go for fluid mechanics, then you will derive this formula also. So the force into distance by area into velocity. If I put the dimensions, then what is the force? m1 L1 t minus 2, then distance is L1 divided by area is L2, and velocity is L1 t minus 1. So now if you do this one, this L2 get cancelled with L2, L1 and L1 L2, right? Then this t minus 1 goes up and L1 goes up, so we will find m1, okay? Then L goes up, then that is L minus 1. So t minus 1 goes up, then this will be t minus 1. So this is the coefficient of viscosity. So the coefficient of viscosity is, the dimension of coefficient of viscosity is m1 L minus 1 t minus 2. And in this one, if you find the SI unit, the SI unit is kg, for m1 kg, length meter minus 1, and time second minus 1. So this is the SI unit of coefficient of viscosity. Clear? Then the next is another one is the gravitational constant. So this term comes in your gravitation. When you read about the gravitation, means the force between two massive bodies. The force between two massive bodies, that is the gravitation. In that gravitation, you will find a physical quantity that is called as a gravitational constant. So if I write this gravitational constant, if I want to find the dimension of gravitational constant. So what is this dimension of this gravitational constant? That is capital G. And already you know acceleration due to gravity is small g. Gravitational constant is represented as a capital G. What is this gravitational constant? This is also called as a universal constant. If there are two massive bodies, according to Newton, if there are two massive body means two bodies having mass, and separated by a distance, there is a force of attraction between the two bodies, and that force of attraction, the force of attraction between the two bodies is given by, a constant into mass of the two bodies, suppose m1 and m2, by r square, distance square. So that force is inversely proportional to r square and product of the masses, and it is proportional. So if you make it equal, then you will get a constant. You have to multiply this constant, that is called gravitational constant. And this is a universal constant, means whenever this is applicable on the surface of earth, and this is also applicable on the planets or any other planet, or if you go to galaxy, to any other star, it is also applicable. Means this law is a universal law. Also this law is also called as a universal law. So from this expression, if I find the dimension of gravitational constant, G is equal to, I can write force into distance square, divided by m1 into m2. So these are the masses. So in dimension there is no difference. I can write this as mass square, right? So I can write mass square. Then from here we will get this force is equal to m1 L1 T minus 2 and distance is L2 divided by m2. So if you write this as m minus 2 plus 1, that is m minus 1, L3 and T minus 2. So this is the gravitational constant. This is the gravitational constant. And if you write the SI unit, always I will discussing for SI, that is equal to kg minus 1, meter cube and second minus 2. Or from this formula also you can find out, that is force is Newton and distance is meter square and mass is kg2. So Newton meter square per kg square. Okay. So this is the dimension of gravitational constant. Similarly, another quantity is called as the gravitational field strength. Gravitational field strength means what? When you find the gravitational constant, then if there is a massive body on the surface of Earth, it will produce its gravitational field around it. So if it produces, so next is the gravitational strength, gravitational field strength. You can say that is the gravitational field strength. So what is this gravitational field strength? If there is a massive body, it produces a magnetic field, it produces a field. That field is called as the gravitational field. If I have a mass, then I will produce a field around me, so that another body comes in that region, it will attract it because of force of gravitation. So from that we got that the gravitational field strength means what is the force experienced by a unit mass placed at that point. So means if I am standing here, I have a gravitational field in this hall. So if someone enters in this region or in this room, then there is a force of attraction between us. If he is not in this region, means in my field region, then there is no force of attraction. So on that basis, the gravitational field strength, the formula is the gravitational constant G into mass, let me write like this, Gm by r square, distance square. But what distance? The body is there. So this is equal to, already you know the gravitation of G. What is the gravitational formula of G? M minus 1. Now we derive M minus 1 L3 T minus 2. We derive this M minus 1 L3 T minus 2. Okay. M minus 1 L3 T minus 2. Then for mass this is M1 and for r square this is L2. So if you put this one M minus 1, then L3 and 2 minus 2, so L1. So M minus 1 plus 1, so M0. Let me make this M0. L1 T minus 2. M0, this is M0 L1 T minus 2. Then what is its unit? You will write. So meter is 0, so length is SI unit. If you find the SI unit from here, L1 it depends on the dimension what? L1. So L1 means meter 1 and second minus 2. You can write M1 second minus 2. Clear? Similarly, another is called as the gravitational potential. Means with what strength what is the strength of the gravitational field? What is the strength of the gravitational field at that point? That is the potential. So the gravitational potential, the formula for gravitational potential is equal to Gm by r. That is r square for field strength, and for gravitational potential it is Gm by r. Okay. So if you find this Gm by r, then I can write this as The dimension of G is m minus 1 L3 T minus 2. M minus 1 L3 m minus 1 L3 T minus 2. Then mass is m1, then L1. So this is equal to m0, clear? L2 T minus 2. So m0 L2 T minus 2, right? Then this unit you can write, SI unit. I can write this as a meter square second minus 2. So this is another physical quantity to find the dimension formula. Okay. Next, another physical quantity we will go for, another physical quantity, that is, I will go for another physical quantity like that. Now go to the another physical quantity, that is your moment of force. What is that? Moment of force. Moment of force. What is this moment of force? This is also, you can say that, torque. It is the force acting on the body when the body is in rotational motion. Suppose I am rotating about an axis, and what is the force acting on me? That is called as the moment of force. Generally, when I am moving in a straight line or in a linear path on a translational motion, then the force acting is, that is F. But in rotational motion, what is the force acting on the body? If rotational motion means the body is rotating about an axis, so the moment of force is the force into the distance. Force into the distance. So what is this distance? Distance is the from the axis, how much distance is the body, about what axis I am rotating. Okay, so that force into distance. So force is m1 L1 T minus 2 and distance is L1. So this is m1 L2 T minus 2. And this is the dimension, it is always written in a square bracket. That is the moment of force. If you write the SI unit, this means SI unit will give you, what is that SI unit? kg meter to second minus 2. This is the SI unit of moment of force. Okay, kg meter square second minus 2. Then another one is called as your angle. Go for the angle. Let me go for this another physical quantity, that is your angle. So when you calculate this angle, that is generally taken as theta. This angle is what? Angle is nothing but your length of arc by radius. Already you know that angle is the length of arc by radius. So from here where it comes, angle means, suppose this is the body and suppose this is the circular motion, or any body is rotating like this. So this is the radius, this is the radius, and this is the angle theta. So this is the arc L by r, length of arc by radius. This is called angle. So what is this angle? Length of arc by radius means length is L1 and radius is L1. So what is the unit here? That is equal to L0, or I can write M0 L0 T0. Clear? So M0 L0 T0, that is the angle. And generally this is arc point. So S unit is unit, we can say, already this is angle, plane angle. So the unit already you know that radian. From here you don't take this is unit, its unit is radian because it is a fundamental physical quantity. Okay. Then from here we can go for the angular displacement. From angle you can say the angular displacement. What is this angular displacement? When a body is in circular motion like this, when a body is rotating in a circular motion, angular displacement, that is also taken as theta. That angular displacement, the same concept here. What is the angle? That is the angular displacement. If the body is rotating in a circular path about this axis, this is the center O, about this axis the body is rotating. So in that case, how much angle it softened at the center when it goes from point A to B. If you go from point A to B with some in a time, then how much angle softened here? That is called as the angular displacement. Like in your linear displacement is it is the distance from the it is from what? Final to the initial position. If I start from here, I reach at a final point and I am starts here, then the total final distance minus the initial distance. The final minus initial is the displacement. Similarly, angular displacement means if the body is in a circular motion. So angular displacement is also having the same dimension, that is your m0, l0, t0. That is the angular displacement. Okay, and its unit is I will write this as SI unit as radian. SI unit is radian. Clear? Then we will go for angular frequency. What is this angular frequency? So angular frequency is the how much is the angle subtend in a time. So next is the angular frequency. What is this angular frequency? How much angle subtend in a time, that is called as the angular frequency. If you consider time, angle by time is the angular frequency, and if you write this m0, l0, t0 divided by time is t1. So this is equal to t minus 1. Right? So this is the t minus 1. Okay, and this t minus 1 means the SI unit is second minus 1. The SI unit is your second minus 1, and remember one thing, there is a t minus 1, but this is from angle, so angle should be radian, so I will write the unit as radian per second. This should be radian per second. If you write second inverse, then it is wrong, because angle has an unit, has no dimension, but SI unit is radian, so that is radian per second. Clear? Then we will go for the trigonometric ratio. Then we will go for the, okay, so another part you can say that from this one we will go for angular velocity. Like your velocity, linear velocity, similarly your angular velocity. What is this angular velocity? Same concept is here, that if the body is rotating like this with origin at the origin and it rotating, so if there are two positions A and B, then what is the angle obtained in what time? That is called as the angular velocity. What is the angular displacement in what time? That means angular displacement divided by time. That is called as the angular velocity. So angular displacement means what? m0, l0, t0, time is t1. So if you write this is equal to t minus 1, that is the dimension, and the unit is simply radian per second. So both are same, unit and dimension, angular velocity and angular frequency, right? That is angular frequency, that is generally written as omega. It is not W, it is omega, pronounced as omega. Clear? Then the next part is your, from here again we will go for angular acceleration. What is this angular acceleration? Angular acceleration is nothing but your angular velocity, like your linear, angular velocity divided by time. What is this angular velocity in what time? That is called as your angular acceleration. And remember students, it is very difficult to remember this formula now for you, but when you go for circular motion, rotational motion, these chapters are there in your syllabus. When you discuss these chapters, then you will get a more clear idea about this concept. Clear? You will get a more clear idea about the concept. So I am not going in detail about the physical quantity. For the time being, you remember this formula, because we will use this dimensional analysis and we will go for further studies. So that's why for the time being you have to remember this physical quantity. So angular velocity by time. So what is this angular velocity? Already you know that is equal to t minus 1 divided by t1. So angular acceleration is equal to t minus 1, right, divided by t1. So this will be equal to t minus 2. But don't write second inverse, that is there is a radian, because velocity involves radian. It is radian per second divided by time, so radian per second square. Okay, that is the SI unit for angular acceleration. Similarly, another quantity is called as your moment of inertia. In the same rotational motion, we will go for another physical quantity, that is called as your moment of inertia. So what is this moment of inertia? Like in your translatory motion, when you read about Newton's law, from there you know that inertia. What is this inertia? Simply inertia means inertia is the property of a body by virtue of which it does not change its position. It does not change its position, or you can say it does not change its state. State means what? If I am in motion, I will be in motion, and if I am at rest, I will be at rest. That is called as my inertia, and this inertia depends on mass. But a moment of inertia that comes in your rotational motion. Similarly, if a body is in rotational motion, moment of inertia comes in rotational motion. So this is generally written as I, moment of inertia. I is equal to, it is in rotational motion. Similarly, if a body is in rotational motion, if a body is rotating about an axis, then in rotational motion, the body has an inertia. It does not change its path, or it will remain in rotational motion. That property is the moment of inertia, and to find the moment of inertia, the formula is mass of the body into distance square. Distance means it is what is the distance of the body from the axis of rotation. So mass into distance square. So if you find the dimension, this is m1, L2. That is the dimension. Distance is L2. So SI unit will be, what will be its SI unit? SI unit is kg meter 2. Kg meter 2. That is your moment of inertia. Okay. Similarly, another quantity is called as your angular momentum. Similarly, another quantity is your angular momentum. Angular momentum. That is taken as L. What is this angular momentum? Angular momentum is like your, what is a linear momentum? Linear momentum is mass into velocity. And remember, there is a relation between the angular and translatory. In translatory means in linear motion and angular motion. In linear motion, when you are telling about the momentum, is the motion contained in the body. Similarly, angular momentum means when a body is in angular or in a rotational motion, then the motion contained in the body, that is called angular momentum, and this angular momentum actually depends on what are the factors? That is the moment of inertia, moment of inertia into the angular velocity. Because when you are discussing about linear, that is mass into velocity. For angular case, mass is replaced by moment of inertia, means you can say that the moment of inertia has the same role as mass in linear motion. So moment of inertia into angular velocity. Then what is the moment of inertia? m1 L2, angular velocity is what? T minus 2. So this is equal to m1 L2 T minus 2. So this is the dimension of angular momentum. What is that angular momentum? That is equal to m1 L2 T minus, okay. So m1 L2 T, okay. So angular velocity is not T minus 1. So this is equal to T minus 1. So m1 L2 T minus 1. Okay. So from here you can write this is the unit is kg meter square second minus 2. SI unit is kg meter square second minus 2. Okay. Similarly, next quantity is your time period. Already you know that what is the time period? That time period means what? What is the total time taken by a body to complete one rotation? If I complete one rotation, from here I start and I come to here, then what is the total time taken? That is called as a time period, and the time period is same as that of time. So the time period has the same dimension. The time period has the same dimension of time. So this is equal to T1, and the unit is second 1. That is the time period, second 1. Clear? So this is the unit of time period. Similarly, another quantity called as your frequency. What is that frequency? Frequency is nothing but it is the reciprocal of time period. Means in 1 second, how many times I complete the rotation? Complete rotation, right? In 1 second, how many times I complete this rotation in 1 second? That is called my frequency. So 1 by time period. That is 1 by time period. So if you put that T minus 1, because 1 by T, that is equal to T minus 1. This is the dimension formula. And unit is what? Second minus 1. So this is your what? Called as a frequency, right? Then next is the another physical quantity that is called as your Planck's constant. So these are about the physical quantities in rotational motion what we come across. Then there are other physical quantities are also there. You can go for another other physical quantities. Then the next one is the Planck's constant. The another physical quantity that is comes in our discussion is Planck's constant. So this Planck's constant. What is this Planck's constant? Another quantity is the Planck's constant. And this is a very important physical quantity that is represented H. And as it is a constant. So what is this Planck's constant? Actually this Planck's constant relates here the energy of a photon. Photon is the light particles. The light particles carries energy. How much is the energy? That is equal to Planck's constant into frequency. So according to that, the energy carried by the light particles, that is called photon, which is equal to h nu. That is given by Max Planck. According to the name of the scientist, it is named so Planck's constant. So h is equal to, I can write energy of photon divided by frequency. That is the formula. Clear? Energy of photon divided by frequency. So already you know that what is the energy of the photon? Energy is the same dimension. So energy means already the m1 L2 T minus 2 energy. Similarly frequency is what? T minus 1. So this is equal to m1 L2 T minus 1. This is plus 1 minus 2 plus 1 m1 L2 T minus 1. And what is the unit here? kg meter square second minus 1, or from here also you can write joule into second, because this is second inverse, that will go up. So joule and second, joule into second. That is the SI unit of Planck's constant. Then another is the heat. If you go heat, so heat is a form of energy. So what is the dimension of energy? That is the dimension of heat. Remember, what is the dimension of energy? That is the dimension of heat. So what is the dimension of energy? That is the m1 L2 T minus 2. So that is the same dimension. Okay, and its unit is generally you can say that calorie, or that is joule. We can express that calorie or joule. Okay, but if you use the SI system of unit, then generally we will take this as energy as what? Only joule. One physical quantity are advantages of SI. One physical quantity, it is a rational system. In SI, it should always express as a joule. Okay. Then another is called as another physical quantity, that is called as your, in that heat part, latent heat. Another physical quantity, that is your latent heat. Latent means what? Hidden. Latent means hidden. How much is the energy hidden? So that is called as latent heat. Latent heat, L, generally taken as L. So that means when a substance changes its state, take ice and you boil the ice, right, and you give heat to the ice. So if heat is given to ice, then ice melts and it becomes water. So ice is the solid state and water is the liquid state. So the solid changes its state to liquid. So during the conversion, as you know, the ice melts at 0 degree centigrade. So at 0 degree centigrade, the ice starts melting. So if the ice is at a minus 5 degree centigrade, that is the ice, and at 0 degree centigrade, the ice changes its state to water. So the solid changes to liquid means, in that case, when solid changes to liquid, in this case, some heat is given, but there is no rise in temperature. Generally, the heat is given to a body means by knowing the temperature, we can say that yes, heat is given to the body. But without giving or without rising the temperature, if heat is given and the body is not rising its temperature, then we can say the heat supplied is hidden or latent in the body. So that latent heat is equal to, the formula for this latent heat is equal to, that formula is for latent heat is equal to heat energy. What is the heat energy given to the body divided by the mass of the body? Heat energy divided by mass of the body. So that is the formula for latent heat. So heat energy is m1 L2 T minus 2, that is the energy, divided by mass m1. So this is equal to L2 T minus 2, m0 L2 T minus 2, right? M0 L2 T minus 2. So you can write M0 L2 T minus 2 or simply L2 T minus 2. So that latent heat means the unit we can write for heat energy, it is joule per mass, that is your kg, joule per kg, right? So this is the unit, that is the joule per kg, or from here also you can say meter square second minus 2, that is the unit for latent heat. Then another in heat phenomena, another physical quantity that is comes in here is the specific heat capacity. Specific heat capacity. So that is generally taken as S or C like that. What is the specific heat capacity? The specific heat capacity means what? It is the heat energy required. Heat energy. What is the heat energy required per unit mass of a substance to rise its temperature? To rise its temperature through 1 degree centigrade. Take a unit mass of substance 1 kg, rise its temperature 1 degree centigrade, then how much heat energy is given? That is called specific heat capacity. So already you know that heat energy is equal to M1 L2 T minus 2, mass is M1 and temperature is Kelvin. So temperature is unit to what? So dimension formula is K1. Now we are using the another physical quantity, that is your K1. So if you write this is equal to mm get cancel, so M0 L2 T minus 2 K minus 1. So this is the dimension M0 L2 T minus 2 K minus 1. Okay, and if you put that, the units are, you can write meter square second minus 2 and Kelvin minus 1. So that is your Kelvin minus 1. Or from here you can write joule per kg, joule per kg, temperature is Kelvin, joule per kg into Kelvin. So this is the specific heat capacity. Then another one is called as your gas constant. Gas constant, already you know that in your chemistry, you are reading about the chemistry, the gas equation. So ideal gas equation, there you are getting this term, that is called as your gas constant. So what is this gas constant? So next is the gas constant. Gas constant R. That is also called as the universal gas constant or molar gas constant. Universal gas constant or molar gas constant. So as you know, pressure into volume is equal to number of mole into R into T. Gas constant into temperature. This is an equation that is called as your ideal gas equation. If a gas is an ideal gas, when the gas is said to be ideal, then if it follows this equation, its pressure into volume, that should be equal to number of mole of the substance and gas constant into T. So from here you will find R is equal to pressure into volume divided by R and number of mole, N is the number of mole into temperature. Number of mole into temperature. So this is the formula for gas constant. Okay. So if you put the values like here, pressure and volume, right? So that is the pressure and volume. If you write the pressure is force by area. Pressure is what? The force per area. So force by area means M1 L minus 1 T minus 2, right? That is the pressure, and volume is L3 number of moles. Already this is a physical quantity, fundamental in SI. So number of moles, I will take this as mole into temperature. Temperature is Kelvin. So this is equal to M1 L2 T minus 2 K minus 1 mole minus 1. So this is the dimension. It involves all the 5, M1 L2 T minus 2 K minus 1 mole inverse. Suppose you take for 1 mole, if this is 1 mole, then you will erase this mole. So this is for n number of mole, I have taken this is the answer. If you write the unit kg, meter square, second minus 2, Kelvin minus 1 and mole inverse. They are same as the unit is same. So this is the SI unit of gas constant. Then the Boltzmann constant, there is another quantity that is comes in here. This is also a name of the scientist Boltzmann, and from there, according to a name, the physical quantity name so that is called Boltzmann constant. Okay. So that is the Boltzmann constant. Boltzmann constant. That is written as K. What is this Boltzmann constant? The Boltzmann constant is the molar gas constant by Avogadro's number. The gas constant by Avogadro's number. I can write this as a gas constant and take this as a molar gas constant for 1 mole. For 1 mole, that is the molar gas constant. Molar gas constant by Avogadro's number. Already you know what is that Avogadro's number? 1 mole of a substance contains how many number of particles or atoms? That is 6.023 into 10 to the power 23. That is the Avogadro's number. So molar gas constant, already you know that molar gas constant. What is the molar gas constant? Already you derived M1 L2 T minus 2, M1 L2 T minus 2 K minus 1. That mole inverse I will not consider here, because for 1 mole I am considering, divided by Avogadro's number. So what is that Avogadro's number means? That is your M1 L2 T minus 2 K minus 1. Avogadro's number is a number, so it has no unit, so I can write M0 L0 T0. Avogadro's number, it is a pure number, 6.023 to 10 to the power 23. So it is a no number. Okay. So this is equal to M1 L2 T minus 2 K minus 1. So this is the Boltzmann constant. This is the dimension of Boltzmann constant. Okay. So if you write the unit also, this Boltzmann constant is kg meter square, second minus 2, Kelvin minus 1. Without mole, you can take this as the Boltzmann constant. Okay. Then another quantity comes in your heat phenomena. When you read this heat phenomena, you will come across another quantity that is called as the coefficient of thermal conductivity. What is this coefficient of thermal conductivity? Next, another physical quantity, coefficient of thermal conductivity. So from here the name itself shows that is represented as K, coefficient of thermal conductivity, that is K. And what is this K? What will this K be? Is the coefficient of thermal conductivity that comes here. Then this physical quantity determine whether a substance is a good conductor of heat or a bad conductor, or you can say as an insulator. Means heat can pass through the substance. According to this value, if you calculate this value of a substance and you know the value, then whether it is a good conductor or a bad conductor, we can know. Good or bad conductor of heat. That's why it is called coefficient of thermal conductivity. Right? So the formula is, for coefficient of thermal conductivity, the formula is the heat energy into the distance or length, you can say distance, or this is the length, and then area into temperature difference, I have written TMP, temperature difference, and the temperature difference, and the next parameter is the time. Next parameter is your time. Okay. So this is your time. So if you put all these cases, heat energy M1 L2 T minus 2, distance L1, area L2, temperature difference K minus 1, temperature is Kelvin, so K minus 1, and the time is second, so time is T, dimension is T1. So if you put all these things, M1, this L2 get cancelled, so I can write this as L0, L2 cancel, then T1 this goes off, T minus 3. Okay, so there is L1 is here, so M1 L1 T minus 3 and K plus 1. See, this is correct. M1 L1 T minus 3 m1 L1 T minus 3 K minus 1. And if you write the unit kg meter second minus 3 Kelvin 1, that is the unit. Okay. So this is the coefficient of thermal conductivity. Next, another parameter you can go for the from the luminous intensity. I am touching all the 7 physical quantities where they are coming. One of the physical quantity involving the 7 fundamental physical units or the fundamental physical quantities. I am touching like that. There are so many physical quantities because physics is a very vast topic. You will get so many physical quantities, but in this portion I am only discussing about one of the parameter like that. Another one is the another physical quantity that is here called as the intensity of illumination. Intensity of illumination. Intensity of illumination. So this is the parameter comes in your optics. If you see an object, means because of its illumination, means because of its illumination, you are getting an object or you are finding an object. So the object is giving some energy. Light is a form of energy, so it is giving some energy. What is that intensity of illumination? The intensity of illumination is the luminous intensity by distance square. Is the luminous intensity by distance square. So luminous intensity, already you know that. What is the luminous intensity? The luminous intensity is that is candela CD for dimension, CD written as CD divided by L2. So I can write this L minus 2 CD1. L minus 2 CD1. Okay. So this is the L minus 2 CD1. Okay. And unit is meter minus 2 candela. And unit is meter minus 2 candela. Okay. Then another physical quantity, suppose I will take this as from current chapter. From current chapter, if I take another physical quantity, that is, you can say for another physical quantity for current, that the most important factor is that charge. Already you know that charge. So out of the charge is a physical quantity. So charge is what? What is the current, which is a fundamental current into time. Current into time. So for current, for dimension, we are taking A1 and time is T1, that is the charge. How much current in a time, that multiply that thing, that is called as the A1 T1. So I can write this as a T1 A1. The sequence is written like this, M L T A K, like that. So that's why I have taken T1 A1, or you can write A1 T1, no problem. And its unit is in SI unit, according to this one, ampere is the current and time is the second. Ampere second, or that is also called as the coulomb. And what you know about current? What is current? The current is what? The rate of flow of charge. The rate of flow of charge. Charge per unit time through a unit cross sectional area. Through a unit cross sectional area, how much charge is flowing in unit time, that is called as a current. So from that, charge is equal to current into time. Current is a fundamental physical quantity in SI and time is a fundamental, so we will get this one. Okay, so this is your current. Okay, similarly from here also we will get another physical quantity that is called as the electric potential. Suppose I will find what is this electric potential, like gravitational potential. Here I will find out the electric potential. What is this electric potential? Then I will take taken as B. The electric potential V is equal to, that is the work done by charge. Work by charge. So what is work? M1 L2 T minus 2, same. Work is what? M1 L2 T minus 2, and charge is already derived. A1 T1 or T1 A1. So this is equal to M1 L2 T minus 3 A minus 1. M1 L2 T minus 3 A minus 1. Okay. So if you write this one, kg meter square second minus 3 ampere minus 1, or simply this is written as a volt. This is represented as a volt. Writing all these things, instead of writing this one, you can write this as a volt. Okay, that is your electric potential. Similarly, like your electric field intensity. Similarly, electric field intensity, like your gravitational field intensity. Electric field intensity is what? Gravitational field intensity, as I told that, the gravitational field intensity comes because of what? There is a massive body. The electric field intensity comes due to a charged particle. So, electric field intensity, the electric field intensity E. What is that electric field intensity? Force, electric force, because electric field intensity, so electric force by charge. So, electric force is equal to M1, L1, T minus 2, the same force. Charge is A1, T1. So, this is equal to M1, L1, T minus 3, M1, L1, T minus 3, A minus 1. So, this is my electric field intensity. If you write the unit kg, meter, second minus 3, ampere minus 1, or simply that is written as a Newton by Coulomb. Coulomb is the unit of charge, already you know that. Okay. So my point is that here I come across, or we got the dimension of some of the physical quantities. What I can recall, I am doing the dimension of the physical quantity. But remember, this is not the sufficient for your dimension. So the my point is here, when you go through this unit and dimension chapter, this dimensional analysis, so remember one thing, that there are so many physical quantities in physics. So it is not easy for a student to know or to write the dimension of all the physical quantities in a 5 in 7 pages. So in due course of time, you will get the physical quantity and you can know the dimension. The point is that how we will calculate the dimensional formula, that is the most important, and you should know that. That is my point. Then the next part is your from this dimension, the next one is the classification of the physical quantity, or you can say the categories of physical quantity on the basis of dimension and its value. On the basis of the dimension of a physical quantity and its value, the physical quantity are divided into 4 categories. So next is the categories of physical quantity. Categories of physical quantity. What it means? Categories of physical quantity means, here you will know that according to the dimensional analysis, or according to the dimensions and value of the physical quantities according to the dimensions and value of physical quantities, means a physical quantity has a dimension and has a value. So according to the dimensions and the value of physical quantities, value of the physical quantity, the physical quantities are of 4 categories. What are they? First, the categories are like your first one is the dimensional constant. One type of physical quantities, they are called as the dimensional constant. Means what the physical quantity that we can divide into 4 categories. Already you know fundamental physical quantity and derived physical quantity, that is on the basis of dependence. Which physical quantity depend on what? The fundamentals does not depend on other quantities, but the derived depend on fundamental. So accordingly they are divided into 2 types. So all the physical quantities on that basis, they are of 2 types. On the dimension part, when you read about dimension, when you know about dimension, then on the basis of this dimension and its value, the physical quantity are of the 4 categories. Dimensional constant, number 2 is the dimensional variable, dimensional variable. Number 3 is the dimensionless constant, and fourth one is the dimensionless variable. Dimensionless variable. Okay. So first I will go for dimensional constant. From the name you can show that the physical quantities which are having dimension, and their value, or you can say having dimension and have a fixed value, means a constant value, have a fixed value. These are called dimensional constant. Like your gravitational constant G. I am writing the notation. Dimensional constant G, gas constant, universal gas constant, right? Planck's constant H, Boltzmann constant K. These are dimensional. They have dimension. G, gravitational constant is dimension. R, gas constant has a dimension. It is not M0, L0, T0, all are 0, not zeros. They have dimension. Planck's constant has a dimension. It has Boltzmann constant has a dimension. But their value is constant. Their value never changes. So these are the dimensional constant. Okay. Then the dimensional variables are the physical which possesses dimension and have no fixed value because they are variable, have no fixed value, possesses dimension and have no fixed value. Like your most of the physical quantity comes under that. You can say velocity, acceleration, force has dimension, possesses dimension and fixed. It's not fixed. The force, you can say the force here is applied is 3 Newton. At another place you can say the force applied is 7 Newton. So the value is changing. So that's the meaning. Velocity, acceleration, force, impulse, work. Clear? So these are the dimensions. So if you say that temperature also, the temperature, electric current, they are dimensional variables. Then the dimensionless constant. What is the dimensionless constant? Dimensionless constant means has no dimension. Dimensionless means no dimension and have fixed value. No dimension and have a fixed value. So remember, so far what we have discussed, a physical quantity have no dimension but have a fixed value. So no dimension and a fixed value is like what? You can say, as I have already told that, if I take half, what is its dimension? No dimension. And it's constant. Has a fixed value. Half is always half. Similarly, your pi has no dimension but a constant. Then exponential function e. Similarly, your logarithm log 5, base e or base 10 you can take. These are the constants. They have the constant value and have no dimension. Okay. Then fourth one is the no dimension, because dimensionless, so it is no dimension and have no fixed value and have no fixed value. Okay. So they have no dimension and have no fixed value. Okay. So from here we can say have no dimension and have no fixed value. What are the quantities like? Already you know that strain. Clear? Then the other one is the strain specific gravity. They have no dimension and have a no fixed value, because the strain, if you apply a more stress, the strain will be more. It has no dimension but the value is fixed. sorry, the value is not fixed but have no dimension. Its dimension is m0, l0, t0. Specific gravity also, you are comparing the density of the substance with respect to water density, means comparing the weight of the substance with respect to the same volume of water's weight. So that on that basis the physical quantity are of 4 categories. Okay. So yes students, this is the categories of a physical quantity on the basis of this dimension and the value or the fixed values of the physical quantities. Okay. Go through these dimensions of the quantities, and as I already told that this is not the number what I have discussed so far, that is not the all the physical quantities what come in our day to day life in our physics. So you will get more number of physical quantity and you can get more dimension formula in due course of time. Okay. Thank you.